Hi everybody. Next topic is symmetry. So we've got a bunch of different types of symmetry that we're going to look at today. First one is line symmetry, aka reflection symmetry. So if something has a line of symmetry, then that just means that it has a line that could divide the figure into two congruent halves. And you can have more than one line of symmetry. So like if we look at our first example, we've got this cute little heart right here, and we're drawing a line that cuts it exactly in half. So like you could fold it along the line and both sides would match up. Fun fact, if you've got a regular polygon, so a polygon where both the sides and the angles are the same size, then you're gonna have the same number of lines of symmetry as you do sides. So like a square has 4 sides, groundbreaking, um, and it also has one line of symmetry that'll draw it in half, two, and then those sneaky diagonals. 3, that would divide the figure in half, and 4, that line would divide the figure in half. So 1, 2, 3, 4 lines of symmetry. Next type of symmetry is rotational symmetry. So all that means is that there is a rotation of 1/2 turn, 180 degrees, or less, which would map the figure onto itself. So like this example that's a star, it's possible for me to take this star and turn it 45 degrees and it'll look exactly the same. It would still have this pointy part pointing toward the top if I were to turn it just a little bit. The way that you figure out the angle of rotation, just like we saw before in our last little part of flipped notes, is when you look at our central angle. So like drawing in the central angles divides my shape up into 1, 2, 3, 4, 5, 6, 7, 8 different pieces. So I'm taking that 360-degree circle, dividing it into 8 parts. Each one is 45 degrees. So that would be the rotation that would map the object onto itself. Last kind of symmetry is point symmetry, which is when you can rotate an object exactly 180 degrees and it will be mapped onto itself. The way I think about this one is that the object looks the same right side up and upside down. So for instance, the letter S has point symmetry because if you were to rotate it 180 degrees, aka turn it upside down, it would still look like the letter S. The letter H, that has point symmetry. It looks the same upside down and right side up. However, like my letters, my initials, letter K, oh wait, yeah, that does have point symmetry. It would be the same upside down and right side up. But last name, B as in Brown, nope, not going to be the same right side up and upside down. So yes, yes, no for the point symmetry. Here's an example where we have to think about an object having maybe more than one type of symmetry. So we've got our flag of Switzerland, and we're asked to identify what types of symmetry this flag has. So we're going to start with line and reflectional symmetry. So if I look at this object, I have to think about, is there a way I could draw a line and cut it into two exactly the same pieces? If I draw a line right down here, right down the middle of the, well, that's not a straight line, that is just sad. Let me use one of my tools. Let's use my straight line tool. If I were to draw a line right through the middle, oh, that's a white line. So is that, oh, there we go. If I were to draw a line like right through the middle of this guy, I'd be cutting my flag into two equal pieces. I could draw a line the other way. That would still cut the flag into pieces that were the same. I could draw one here along the diagonal and another one over here along the other diagonal. And each of these is allowing me to cut the flag into two congruent halves. So I guess the answer to my first question, what types of symmetry does the flag have? Do we have line symmetry? That's a yes. And the number of lines of symmetry I drew was 1, 2, 3, 4. Be careful not to count the same line twice. So 4 lines of symmetry. Next one is rotational symmetry. So I'm thinking to myself, is there a way that I could maybe turn this flag and make it look exactly the same? So like if you were to turn your paper 90 degrees or on its side and look at this flag, it would still look exactly the same. So that would make rotational symmetry a yes. And the angle of rotation is 90 degrees. Another way to get that 90-degree rotation measurement is if we think about connecting like the vertices or the points on the side of our polygon to our middle angle, our central angle, our center point. Notice that with a square, I'm dividing my circle or my 360 degrees into 1, 2, 3, 4 equal parts, and we hopefully know that to do 360 divided into 4 pieces, we get our 90 degrees, our angle of rotation. So then the very last question, or the very last type of symmetry, is point symmetry. And that's just me answering the question, does a 180-degree rotation map the object onto itself? AKA, if I turn this flag upside down, is it still going to look the same? You can test it out with your paper if you want to, and hopefully you come to the conclusion, yes. So we've got some practice down there. You can try it out now if you want, or if you want to save it for class, you're now just done with your notes.